Hello friends and welcome to the session on stack and its related instructions. So I will be talking about stack operations in relation to 8085 microprocessor. So let's understand first of all what is a stack. So it is a part of memory location in the read-write memory area which is used for temporary storage of some data during the execution of the program. The features of the stack are, first of all, it works in last in first out structure, which means that the data which has been stored in the last will be taken out or retrieved first. Then the starting location of the stack will be defined by loading a 16-bit address into the stack pointer represented by SP. The instructions which are used for stack operations are push and pop instructions. So the format for writing these instructions are push RP and pop RP. This RP is a register pair which we have studied during the A085 architecture. The three register pairs in this microprocessor are BC, DE and HL. So while writing these instructions push and pop, we have to mention the first name of the register pair, like it's written here, push B, push D, push H, and likewise the pop instructions are written. Now let's understand the execution of the push instruction. So this push instruction writes the data on the stack. Let's understand this with the help of an example. So the instruction written here is push B. Now let's assume that the stack pointer contains the memory address 2000 and the register pair BC contains some 16-bit data which is mentioned here as 1F30. Now this state data will be stored in the register pair BC as shown in this diagram. 1F will make up the higher byte and 30 will make up the lower byte of the data. Now this is the initial position of the stack which is empty and the stack pointer is pointing to the memory location 2000. When this push B is executed, this stack pointer will be decremented and it will now point to the memory location 1FFF, and here the higher byte of the data from register B will be stored. Then the stack pointer will be again decremented and now it will point to the location 1FFE. Here the lower byte which is stored in register C will be stored. Let's take up another example, push PSW. Here PSW stands for program status word. So whenever we want to retrieve the data of accumulator and the flag register, we use the program status word. So again assume that the stack pointer contains the address 2000, accumulator contains an 8-bit data which is represented here by an hexadecimal number 5050. The flag register is also mentioned here in the hexadecimal number as 01. So again this is the initial position of the stack and you can see the stack pointer is pointing to the location 2000. So when this push PSW instruction is executed, the stack pointer will be decremented and it will point to 1FFF, and here the data which is in the accumulator will be stored. Again the stack pointer will be decremented and now it will point to 1FFE. Here the status of the flag register will be stored. Now let's understand the execution of the pop instruction. So this pop instruction read the data from stack. Let's take up an example. The example is pop B. Again assume that the stack pointer contains the address 2000. In the location 2000, the data stored is 50 and in the location 2001, the data stored is 40. So this is the initial position of the stack where you can see that the respective data is stored in their locations. So stack pointer is also pointing to the location 2000. As and when this pop instruction is executed, the data which is stored in the location 2000 will be stored in the register BC. This 50 will be stored as a lower byte in register C. Then this stack pointer will be incremented and it will now point to the location 2001, and this data 40 will be stored in register B as the higher byte. After execution, this is the position of the register pair BC, where you can see that the respective numbers have been stored. And the stack pointer will be again incremented, and in the end it will point to the next location, which is 2002. Let's take up another example of pop PSW, and again assume that the stack pointer contains the address 2000, the location 2000 contains the data 50, and the location 2001 contains the data 01. So pop PSW will make up the data to be retrieved from the stack to accumulator and flag register respectively. So this is the initial position of the stack, where you can see that the stack pointer is pointing to the location 2000. Now this as and when this instruction pop PSW is executed, the data which is stored in location 2000, which is 01, will move on to the flag register. So it is making up the lower byte, of course, and this stack pointer will be incremented. Now it will point to the memory location 2001, and this data 50 will be stored in the accumulator. So after execution, this will be the position. Accumulator and the flag register will contain the respective bytes, and the stack pointer will be again incremented, and it will point to the location 2002. So I hope you have understood the stack operations push and pop. Still you have any query, you can mention it on the comment box. So thank you and happy learning.